Hi everyone, welcome back to chemistry. In this video, we're going to continue talking about chapter 6, and specifically we want to talk about molar mass and mole to mass conversions in this video. So previously we learned about something called atomic mass, and we said that we could find the atomic mass of any given element from the periodic table. And we used the atomic mass units, or AMUs, as our units for representing the atomic mass of these different elements. Well, we can also, now that we know about moles, we can also equate these atomic mass units to something called molar mass. And we express the molar mass in units of grams per mole. So 1 AMU is defined as 1 gram per mole, or 1 gram over 1 mole, right? So the division sign here means per, right? Like miles per hour. And then it's assumed that there's only 1 mole on the bottom, right? Miles per 1 hour rather than miles per, 2 hours or 3 hours, right? It's always assumed miles per 1 hour. Just like it's assumed 1 gram per 1 mole, 1 gram per mole. Okay, and like we said, we can abbreviate moles as MOL instead of having that E there. It doesn't abbreviate it a whole lot, but it's helpful when you're writing this out a billion times. All right, so for example, if we look on the periodic table, we said, okay, we could find the atomic mass of carbon, and looking at the periodic table, that's the bottom number on most periodic tables, and that says 12.018 on my periodic table. And we assume atomic mass units because that's what I told you we measure that atomic mass in, is atomic mass units, or AMUs, or even sometimes U's, just U. Sorry, why isn't it letting me write on here? U. And that's equal to 12.01 grams per mole, right? Because we said up here that 1 AMU equals 1 gram per mole, right? These two things are equal. That's what that equal sign is saying. It's an equality, right? So 1 AMU is 1 gram per mole. And if that's the case, then if we have 12 AMUs of something, we also have 12 grams per mole, or about 12, right? 12.01. Okay, so we know that carbon has a molar mass of 12.01 grams per mole. And notice that we no longer call it the atomic mass because we're not representing it in atomic mass units anymore. Now we're representing it with moles, and that gets the special name molar mass. It's essentially the same thing. We just represent it with different units. And those units are important because they allow us to convert using grams and moles, and we'll learn why that's important. So if we use a balance to measure 12.01 grams of carbon, that means we have 1 mole of carbon, right? Because carbon's molar mass is 12.01 grams per every 1 mole, right? Remember, there's an invisible 1 there. So if we have 1 mole of carbon, that weighs 12.01 grams. It also means, right, if we have 1 mole of carbon, we also know that 1 mole of anything is 6.022 times 10 to the 23rd atoms of that thing, right? 1 mole of carbon is 6.022 times 10 to the 23rd atoms of carbon. So we can write an equality based on all of those relationships, right? That in 1 mole of carbon, there are both 12.01 grams of carbon and 6.022 times 10 to the 23rd carbon atoms, all within that 1 mole. And this is really useful in chemistry for lots of different reasons that we'll get into in a little bit. Okay, for now, let's try calculating the molar mass of NaCl. And I want to stress that this is exactly the same as how you calculate the formula mass or the molecular mass. It's the same idea. We're just now expressing it in these specific units for molar mass, which are grams per mole. Okay. All right, so using the periodic table, let's calculate the molar mass of NaCl. So, and we want it in grams per mole. So Na, when we look on the periodic table, if we're looking at NaCl, we want the mass of this whole compound, the molar mass of this entire compound. So we got to add up the masses of each of those atoms. So in this compound, we have 1 sodium atom, and that sodium atom weighs 22.990. We used to write AMU, right, when we were doing formula mass. Now we're going to write grams per mole. Those are our new units for molar mass. But it's the same idea, right? In fact, this is the exact same thing you'd write down if you were calculating the formula mass. You would just have different units there. All right, and then chlorine, we've still got one atom of chlorine. So I'm just going to note that. And then we have 35.453 grams per mole. All right, so now we got to total this up. And that's going to equal 58.443 grams per mole. So the molar mass, or I sometimes abbreviate that, capital M, of NaCl equals 58.443 grams per mole. So what does this mean? This means if you have 1 mole of NaCl, that weighs 58.443 grams. That's what this molar mass tells you. It's connecting moles and mass. Connecting those two units. All right, let's practice this a little bit more. So calculate the molar mass of H2O. So let's see, we've got 2 H's and 1 O. So I'm just going to write that down. Each H atom, hydrogen atom, weighs 1.008 grams per mole. And remember, I'm getting that from the periodic table, this number. That's the bottom number on the periodic table. And then for oxygen, the periodic table I'm looking at says 15.999 grams per mole. Okay, and now we got to total all of that up, remembering that we have, we got to do this multiplication first. And that's going to give me the total molar mass of my H2O molecule. So molar mass H2O equals 18.015 grams per mole. All right, and then number 2 asks, how many molecules of H2O are in 1 mole? Now, don't let this trip you up. It sounds kind of scary, but remember, we know Avogadro's number tells us that 1 mole of any substance equals 6.022 times 10 to the 23rd units of that substance. So 1 mole of H2O molecules is 6.022 times 10 to the 23rd molecules of H2O. That's how many molecules are in 1 mole of my H2O. Now, the reason that I have these two problems together is because sometimes we're going to want to convert from grams of our substance, any substance, to moles of our substance, and then maybe even to atoms eventually. Okay, and we can do that. We can get from grams to moles to atoms. And we're going to learn how to do that. So the molar mass connects grams and moles, right? Molar mass. We said that connects grams and moles. Those are our units, grams per mole. So if we know the molar mass of a substance, and we know how many grams we start out with, we can get 2 moles of that substance. Likewise, we know something that connects moles to atoms, and that is Avogadro's number, Avo's number. And we can go both ways on here, right? We can go from atoms to moles to grams, and we can go from grams to moles to atoms, using the things that we know that connect those different parts of the problem. All right, so you can use this molar mass, right, grams per mole, as a conversion factor to go from mass to moles or from moles to mass, right, to do this step here. You can use that molar mass as a conversion factor. And just like anything, right, the conversion factor can be split up into 2 different options, right? You can have 18.02 grams of water over 1 mole of water, right? Where am I getting 18.012? That's from this here, right? That's the molar mass of water. So 18.02 grams of water can go on the top, with 1 mole of water on the bottom, right? Grams per 1 mole. Or we can flip that and we can say, okay, we have 1 mole of water on the top and 18.02 grams on the bottom. So if we want to get if we want the final answer in any problem to be expressed in grams, then we're going to want to put grams in the numerator on top because we want to cancel out whatever's on the bottom. If we want our final answer in moles, right, we're going to put moles on the top because we're going to want to cancel out grams on the bottom. And this will make more sense as we do an example. All right, so let's try this out. And noting that we've got our 2 conversion factors up here. And actually, let me write that down. Conversion factors using molar mass. Right, the molar mass of water, actually, I should say. All right, and the first question asks, what is the mass in grams of 2.3 moles of water? What is the mass in grams of 2.3 moles of water? So just before we do anything, let's break this down a little bit. It looks like I want to convert from moles of H2O to grams, right? Grams H2O. All right, what do we know that connects grams and moles? Yeah, molar mass, right? Molar mass connects grams and moles. Grams and moles. That's why the molar mass is so useful and why it exists and why we don't just use the atomic mass in atomic mass units. Okay, all right, so we're always going to start with what we're given for these. So I was given, this is the only number I'm given in this equation. Or in this problem. So 2.3 moles of H2O is what I'm starting with. So that's going to be my first kind of train track, or my first fraction. Remember, this is an imaginary fraction, right, with an imaginary 1 under it. All right, so we know we need to pick a conversion factor. We need either this one on the left or this one on the right. Now, if we want to get from moles of water to grams of water, what needs to go on top, grams or moles? Yeah, grams needs to go on top. Remember, if we're trying to convert to grams, we want to cancel out anything that's not grams, right? So we need 1 mole of H2O. Why 1 mole and not 2 or 3 or 4? Yeah, because the molar mass is expressed in grams per mole, grams per 1 mole. All right, so we've got 1 mole of water, and in 1 mole of water, 1 mole of water is going to weigh 18.02 grams. All right, and now we can cancel out those moles of water, and we're left with the unit we wanted, which was grams of water. So let's go ahead and multiply this out. So we've got 2.3 times 18.02, and that equals 41.446 grams of H2O. All right, and then it looks like, we start with 2 sig figs. So 2 sig figs is here for our measured value. And then we usually report molar mass in 4 sig figs. So generally for our class, we'll probably always have, the lowest number of sig figs as our measured value. And then you're going to take the lowest number of sig figs for your final answer, right? Because we're multiplying or dividing. So this final answer is just going to be 41. I'm going to round that to 41. So we have 2 sig figs, and that's our final answer. All right, so how many moles are in 4.2 grams of H2O is our next question. So before, we started with moles, and we wanted to get to grams. Now we're starting with grams, and we want to get to moles. So grams of H2O, 2 moles of H2O. That's our goal. All right, so we start with the number that we're given, right, which is 4.2 grams, 4.2 grams of H2O. That's our first kind of train track. And then in the next step, we need one of these conversion factors, right? Again, using the molar mass as a conversion factor, because the molar mass is what's going to connect grams and moles for H2O. All right, so we know the molar mass is 18.02 grams per mole. So do grams go on the top or the bottom? Yeah, the bottom, right? Because we want to cancel them out. So 18.02 grams of H2O goes on the bottom. And 1 mole of H2O goes on the top. Now we can go ahead and cancel out those grams of water, and we're left with moles of water. Specifically, we have 4.2 divided by 18.02, and that's going to give us 0.23, and I'll go 2 sig fig, so we'll leave it like that, moles of H2O. So what is this saying? This is saying if you start with 4.2 grams of water, in those 4.2 grams of water, there are 0.23 moles of water. And this kind of makes sense, right? Because this number is less than 1. It's fractional because there's actually in 1 mole of water, there's 18.02 grams. 4 doesn't even really come that close to that. Okay, so we have a fractional amount of moles of water here. All right, so just to recap, and let me just clean this up just a bit so we have a little less going on here. We said, all right, in this first one, we start with what we're given, right? Which is that 2.3 moles of water. We have 2.3 moles of water. And then we use our molar mass of H2O to get from moles of H2O to grams of H2O. Same idea here. We're given the grams of water, right? Instead of moles, we're now given grams. And that's okay. We just got to go the other way, right? But we're still going to use our molar mass, our only thing that connects grams and moles. Okay, grams and moles, connecting those two things. All right, so let's try this again. Let's calculate the molar mass of MgCl2. So we've got how many magnesiums? Yeah, 1 magnesium. And how many chlorines? Yeah, 2 chlorines, right, from here. And now we got to figure out what's the mass of each of those atoms. So for magnesium, looking on the periodic table, we've got a mass of 24.305. What are our units now? Grams per mole. Yeah, grams per mole. That's the units for molar mass. All right, and then for chlorine, what's the mass on the periodic table that's listed? Yeah, 35.453. Again, grams per mole. All right, we're not done. We got to total this up, remembering first that we got to multiply 2 times 35.453 because that 35.453 is just for 1 chlorine, but we have 2 of them. So that gives me a 70.906 plus 24.305. And that's going to give me a total, we'll just write it over here, I guess, of 95.211 grams per mole. And this is, let's just label it the molar mass of MgCl2. Oh, what's the name of this compound, by the way? Yeah, magnesium chloride. Can't forget how to name these compounds. It's an ionic compound. We got a metal and a nonmetal, so we're going to call that one magnesium chloride. All right, now we want to know, we know our molar mass, so we know something that connects grams and moles, right? We know something that connects those two things using our molar mass. So we want to know what's the mass of 0.52 moles of MgCl2. If I don't tell you what to report the mass in, what unit, you're just going to assume that it's grams. Okay, that's the most common one too, and that's the one we work with the most, and you guys are probably pretty familiar with it already. All right, so what's the mass of 0.52 moles of magnesium chloride? So again, we start with what we're given, which is 0.52 moles MgCl2, and we want to get to grams of MgCl2. So what goes on the top? Is it going to be moles of MgCl2 or grams of MgCl2? Yeah, grams has got to go on the top. Grams of MgCl2, and moles of MgCl2 can go on the bottom. Okay, I'm not done though because I didn't put any numbers there. So what numbers go there? Think about it. All right, so hopefully you thought about it. Remember, this piece here is our molar mass. That's what connects grams and moles. So the number of grams is given by the number of grams in your molar mass, which is 95.211 in this case. And then what goes on the bottom? And sorry, I should have removed that S there. What goes on the bottom? Yeah, just 1 mole, right? The molar mass is reported in grams per mole, grams per 1 mole. Right? When we say miles per hour, we're not talking miles per 2 hours, miles per 3 hours, right? Miles per 1 hour, just 1. Okay, so now we can cancel out those moles. Cancel. And we're left with grams on the top, which is great because whatever you're left with on the top right is going to be your units for your final answer. So we've got 0.52 times 95.211. And that's going to give us 23.80275 grams of MgCl2. And then let's just double check. So here we've got 5 sig figs. Here we've got 2 sig figs. So we're going to go with 2. So that means I need to round to here. And let's make that 24. And we'll scooch this up here.